Welcome back. It's Sunday. I got up again and I'm sleepy and I feel a little sick. Just eat a little food and got a bit water. So it's 10:30. Let's read the one aircraft. Maybe we can read this Airbus 320 today. And no, 310 and 300. But I like to make a video about it in my language Danish after reading. It was supposed to be in English too, but I'll not do that because I'm getting tired and old. I need to get to my bed. I just like reading to relax, to learning something new. I not just like to read about aircrafts. I like to read about history. Stuff like this. I need to read later, but not today.
Cabin 5.64.
Okay, that's
Airbus A300. A300 redirects here. For other uses, see A300, disambiguation. The Airbus A300 is Airbus' first production aircraft and the world's first twin-engine, double-aisle, wide-body airliner. It was developed by Airbus Industrie GIE, now merged into Airbus SE, and manufactured from 1971 to 2007. In September 1967, aircraft manufacturers in France, West Germany and the United Kingdom signed an initial memorandum of understanding to collaborate to develop an innovative large airliner. The French and West Germans reached a firm agreement on the 29th of May 1969, after the British withdrew from the project on the 10th of April 1969. A new collaborative aerospace company, Airbus Industrie GIE, was formally created on the 18th of December 1970 to develop and produce it. The A300 prototype first flew on the 28th of October 1972. The first twin-engine wide-body airliner, the A300 typically seats 247 passengers in two classes over a range of 5,375 to 7,500 kilometers, 2,900 to 4,015 mi. 3,340 to 4,660 mi. Initial variants are powered by General Electric CF6-50 or Pratt & Whitney JT9D turbofans and have a 3-crew flight deck. The improved A300-600 has a 2-crew cockpit and updated CF6-80C2 or PW4000 engines. It made its first flight on the 8th of July 1983 and entered service later that year. The A300 is the basis of the smaller A310, first flown in 1982, and was adapted in a freighter version. Its cross-section was retained for the larger four-engined A340, 1991, and the larger twin-engined A330, 1992. It is also the basis for the oversized Beluga Transport, 1994. Unlike most Airbus products, it has a yoke, not using a fly-by-wire system. Launch customer Air France introduced the type on the 23rd of May, 1974. After limited demand initially, sales took off as the type was proven in early service. beginning 3 decades of steady orders. It has a similar capacity to the Boeing 767-300, introduced in 1986, but lacked the 767-300 range. During the 1990s, the A300 became popular with cargo aircraft operators, as both passenger airliner conversions and as original builds. Production ceased in July 2007 after 561 deliveries. As of September 2023, there are 197 A300 family aircraft still in commercial service. Development, edit. Origins, edit. During the 1960s, European aircraft manufacturers such as Hawker Siddeley and the British Aircraft Corporation, based in the UK, and Sud Aviation of France, had ambitions to build a new 200-seat airliner for the growing civil aviation market. While studies were performed and considered, such as a stretched twin-engine variant of the Hawker Siddeley Trident and an expanded development of the British Aircraft Corporation, BAC 111, designated the BAC 211, it was recognized that if each of the European manufacturers were to launch similar aircraft into the market at the same time, neither would achieve sales volume needed to make them viable. In 1965, a British government study, known as the Plowden Report, had found British aircraft production costs to be between 10% and 20% higher than American counterparts due to shorter production runs, which was in part due to the fractured European market. To overcome this factor, the report recommended the pursuit of multinational collaborative projects between the region's leading aircraft manufacturers. European manufacturers were keen to explore prospective programs. The proposed 260-seat widebody HBN 100 between Hawker Siddeley, Nord Aviation, and Breguet Aviation being one such example. National governments were also keen to support such efforts amid a belief that American manufacturers could dominate the European economic community. In particular, Germany had ambitions for a multinational airliner project to invigorate its aircraft industry, which had declined considerably following the Second World War. During the mid-1960s, both Air France and American Airlines had expressed interest in a short-haul twin-engine wide-body aircraft, indicating a market demand for such an aircraft to be produced. In July 1967, during a high-profile meeting between French, German, and British ministers, an agreement was made for greater cooperation between European nations in the field of aviation technology, and for the joint development and production of an Airbus. The word Airbus at this point was a generic aviation term for a larger commercial aircraft, and was considered acceptable in multiple languages, including French. Shortly after the July 1967 meeting, French engineer Roger Betail was appointed as the technical director of what would become the A300 program, while Henry Z. Aguilar, chief operating officer of Sud Aviation, was appointed as the general manager of the organization, and German politician Franz Joseph Strauss became the chairman of the supervisory board. Betail drew up an initial work-share plan for the project, under which French firms would produce the aircraft's cockpit, the control systems, and lower center portion of the fuselage. Hawker Siddeley would manufacture the wings, while German companies would produce the forward, rear and upper part of the center fuselage sections. Additional work included moving elements of the wings being produced in the Netherlands, and Spain producing the horizontal tail plane. An early design goal for the A300 that Betail had stressed the importance of was the incorporation of a high level of technology, which would serve as a decisive advantage over prospective competitors. For this reason, the A300 would feature the first use of composite materials of any passenger aircraft, the leading and trailing edges of the tail fin being composed of glass fiber reinforced plastic. BTAL opted for English as the working language for the developing aircraft, as well against using metric instrumentation and measurements, as most airlines already had US-built aircraft. These decisions were partially influenced by feedback from various airlines, such as Air France and Lufthansa, as an emphasis had been placed on determining the specifics of what kind of aircraft that potential operators were seeking. According to Airbus, this cultural approach to market research had been crucial to the company's long-term success. Work share and redefinition, edit. On the 26th of September, 1967, the French, West German and British governments signed a Memorandum of Understanding to start the development of the 300-seat Airbus A300. At this point, the A300 was only the second major joint aircraft program in Europe, the first being the Anglo-French Concorde. Under the terms of the memorandum, the French and British were to each receive a 37.5% work share on the project, while the West Germans would receive a 25% share. Sudaviation was recognized as the lead contractor for the A300, with Hawker Siddeley being selected as the British partner company. At the time, the news of the announcement had been clouded by the British government's support for the Airbus, which coincided with its refusal to back BAC's proposed competitor, the BAC 211, despite a preference for the latter expressed by British European Airways, B. Another parameter was the requirement for a new engine to be developed by Rolls-Royce to power the proposed airliner, a derivative of the in-development Rolls-Royce RB211, the triple-spool RB207, capable of producing a 47,500 lbf, 211 kN. The program cost was $4.6 billion, in 1993 dollars, equivalent to $8.76 billion in 2023. In December 1968, the French and British partner companies, Sudaviation and Hawker Siddeley, proposed a revised configuration, the 250-seat Airbus A250. It had been feared that the original 300-seat proposal was too large for the market, thus it had been scaled down to produce the A250. The dimensional changes involved in the shrink reduced the length of the fuselage by 5.62 meters, 18.4 feet, and the diameter by 0.8 meters, 31 in, reducing the overall weight by 25 tons, 55,000 pounds. For increased flexibility, the cabin floor was raised so that standard LD3 freight containers could be accommodated side by side, allowing more cargo to be carried. Refinements made by Hawker Siddeley to the wing's design provided for greater lift and overall performance. This gave the aircraft the ability to climb faster and attain a level cruising altitude sooner than any other passenger aircraft. It was later renamed the A300B. Perhaps the most significant change of the A300B was that it would not require new engines to be developed, being of a suitable size to be powered by Rolls-Royce RB211, or alternatively the American Pratt & Whitney JT9D and General Electric CF6 power plants. This switch was recognized as considerably reducing the project's development costs. To attract potential customers in the US market, it was decided that General Electric CF6-50 engines would power the A300 in place of the British RB207. These engines would be produced in cooperation with French firm Snecma. By this time, Rolls-Royce had been concentrating their efforts upon developing their RB211 turbofan engine instead, and progress on the RB207's development had been slow for some time, the firm having suffered due to funding limitations, both of which had been factors in the engine switch decision. On the 10th of April, 1969, a few months after the decision to drop the RB207 had been announced, the British government announced that they would withdraw from the Airbus venture. In response, West Germany proposed to France that they would be willing to contribute up to 50% of the project's costs if France was prepared to do the same. Additionally, the managing director of Hawker Siddeley, Sir Arnold Alexander Hall, decided that his company would remain in the project as a favored subcontractor, developing and manufacturing the wings for the A300, which would prove to be an important contributor to the performance of subsequent versions. Hawker Siddeley spent £35 million of its own funds, along with a further £35 million loan from the West German government, on the machine tooling to design and produce the wings. Program launch, edit. On the 29th of May 1969, during the Paris Air Show, French Transport Minister Jean Charmant and German Economics Minister Karl Schiller signed an agreement officially launching the Airbus A300, the world's first twin-engine wide-body airliner. The intention of the project was to produce an aircraft that was smaller, lighter, and more economical than its three-engine American rivals, the McDonnell Douglas DC-10 and the Lockheed L-1011 TriStar. In order to meet Air France's demands for an aircraft larger than 250-seater 300B, it was decided to stretch the fuselage to create a new variant, designated as the A300B2, which would be offered alongside the original 250-seater 300B, henceforth referred to as the A300B1. On the 3rd of September 1970, Air France signed a letter of intent for 6 A300s, marking the first order to be won for the new airliner. In the aftermath of the Paris Air Show agreement, it was decided that, in order to provide effective management of responsibilities, a groupement d'intérêt économique would be established, allowing the various partners to work together on the project while remaining separate business entities. On the 18th of December 1970, Airbus Industry was formally established following an agreement between Aerospatiale, the newly merged Sud Aviation and Nord Aviation, of France and the antecedents to Deutsche Aerospace of Germany, each receiving a 50% stake in the newly formed company. In 1971, the consortium was joined by a third full partner, the Spanish firm CASA, who received a 4.2% stake, the other two members reducing their stakes to 47.9% each. In 1979, Britain joined the Airbus consortium via British Aerospace, which Hawker Siddeley had merged into, which acquired a 20% stake in Airbus Industry, with France and Germany each reducing their stakes to 37.9%. Prototype and flight testing, edit. Airbus Industry was initially headquartered in Paris, which is where design, development, flight testing, sales, marketing, and customer support activities were centered. The headquarters was relocated to Toulouse in January 1974. The final assembly line for the A300 was located adjacent to Toulouse-Blagnac International Airport. The manufacturing process necessitated transporting each aircraft section being produced by the partner companies scattered across Europe to this one location. The combined use of ferries and roads were used for the assembly of the first A300, however this was time-consuming and not viewed as ideal by Felix Kratt, Airbus Industries production director. Kratt's solution was to have the various A300 sections brought to Toulouse by a fleet of Boeing 377-derived Aerospace Line Super Guppy aircraft, by which means none of the manufacturing sites were more than 2 hours away. Having the sections airlifted in this manner made the A300 the first airliner to use just-in-time manufacturing techniques, and allowed each company to manufacture its sections as fully equipped, ready-to-fly assemblies. In September 1969, construction of the first prototype A300 began. On the 28th of September 1972, this first prototype was unveiled to the public, it conducted its maiden flight from Toulouse-Blagnac International Airport on the 28th of October that year. This maiden flight, which was performed a month ahead of schedule, lasted for 1 hour and 25 minutes. The captain was Max Fischer and the first officer was Bernard Ziegler, son of Henry Ziegler. In 1972, unit cost was US $17.5 m. On the 5th of February 1973, the second prototype performed its maiden flight. The flight test program, which involved a total of 4 aircraft, was relatively problem-free, accumulating 1,580 flight hours throughout. In September 1973, as part of promotional efforts for the A300, the new aircraft was taken on a 6-week tour around North America and South America, to demonstrate it to airline executives, pilots, and would-be customers. Amongst the consequences of this expedition, it had allegedly brought the A300 to the attention of Frank Borman, the CEO of Eastern Airlines, one of the Big Four U.S. airlines. Entry into service, edit. On the 15th of March 1974, type certificates were granted for the A300 from both German and French authorities, clearing the way for its entry into revenue service. On the 23rd of May 1974, Federal Aviation Administration, FAA, certification was received. The first production model, the A300B2, entered service in 1974, followed by the A300B4 1 year later. Initially, the success of the consortium was poor, in part due to the economic consequences of the 1973 oil crisis. But by 1979 there were 81 A300 passenger liners in service with 14 airlines, alongside 133 firm orders and 88 options. 10 years after the official launch of the A300, the company had achieved a 26% market share in terms of dollar value, enabling Airbus to proceed with the development of its second aircraft, the Airbus A310. Design, edit. The Airbus A300 is a wide-body medium to long-range airliner. It has the distinction of being the first twin-engine wide-body aircraft in the world. In 1977, the A300 became the first extended-range twin operations, ETOPS, compliant aircraft, due to its high performance and safety standards. Another world first of the A300 is the use of composite materials on a commercial aircraft, which were used on both secondary and later primary airframe structures, decreasing overall weight and improving cost-effectiveness. Other firsts included the pioneering use of center of gravity control, achieved by transferring fuel between various locations across the aircraft, and electrically signaled secondary flight controls. The A300 is powered by a pair of underwing turbofan engines, either General Electric CF6 or Pratt & Whitney JT9D engines. The sole use of underwing engine pods allowed for any suitable turbofan engine to be more readily used. The lack of a third tail-mounted engine, as per the tri-J configuration used by some competing airliners, allowed for the wings to be located further forwards and to reduce the size of the vertical stabilizer and elevator, which had the effect of increasing the aircraft's flight performance and fuel efficiency. Airbus partners had employed the latest technology, some of which having been derived from Concorde, on the A300. According to Airbus, new technologies adopted for the airliner were selected principally for increased safety, operational capability, and profitability. Upon entry into service in 1974, the A300 was a very advanced plane, which went on to influence later airliner designs. The technological highlights include advanced wings by de Havilland, later BAE Systems, with supercritical airfoil sections for economical performance and advanced aerodynamically efficient flight control surfaces. The 5.64 m 222 in diameter circular fuselage section allows an 8 abreast passenger seating and is wide enough for 2 LD3 cargo containers side by side. Structures are made from metal billets, reducing weight. It is the first airliner to be fitted with wind shear protection. Its advanced autopilots are capable of flying the aircraft from climb out to landing, and it has an electrically controlled braking system. Later A300s incorporated other advanced features such as the forward-facing crew cockpit, FFCC, which enabled a two-pilot flight crew to fly the aircraft alone without the need for a flight engineer, the functions of which were automated. This two-man cockpit concept was a world first for a wide-body aircraft. Glass cockpit flight instrumentation, which used cathode ray tube, CRT, monitors to display flight, navigation, and warning information, along with fully digital dual autopilots and digital flight control computers for controlling the spoilers, flaps, and leading-edge slats, were also adopted upon later build models. Additional composites were also made use of, such as carbon fiber reinforced polymer, CFRP, as well as their presence in an increasing proportion of the aircraft's components, including the spoilers, rudder, air brakes, and landing gear doors. Another feature of later aircraft was the addition of wingtip fences, which improved aerodynamic performance and thus reduced cruise fuel consumption by about 1.5% for the A300-600. In addition to passenger duties, the A300 became widely used by air freight operators. According to Airbus, it is the best-selling freight aircraft of all time. Various variants of the A300 were built to meet customer demands, often for diverse roles such as aerial refueling tankers, freighter models, new build and conversions, combi aircraft, military airlifter, and VIP transport. Perhaps the most visually unique of the variants is the A300-600 ST Beluga, an oversized cargo-carrying model operated by Airbus to carry aircraft sections between their manufacturing facilities. The A300 was the basis for, and retained a high level of commonality with, the second airliner produced by Airbus, the smaller Airbus A310. Operational history, edit. On the 23rd of May 1974, the first A300 to enter service performed the first commercial flight of the type, flying from Paris to London, for Air France. Immediately after the launch, sales of the A300 were weak for some years, with most orders going to airlines that had an obligation to favor the domestically made product, notably Air France and Lufthansa, the first two airlines to place orders for the type. Following the appointment of Bernard Lathier as Henry Z. Aguilar's replacement, an aggressive sales approach was adopted. Indian Airlines was the world's first domestic airline to purchase the A300, ordering 3 aircraft with 3 options. However, between December 1975 and May 1977, there were no sales for the type. During this period, a number of whitetail A300s completed but unsold aircraft were completed and stored at Toulouse, and production fell to half an aircraft per month amid calls to pause production completely. During the flight testing of the A300B2, Airbus held a series of talks with Korean Air on the topic of developing a longer-range version of the A300, which would become the A300B4. In September 1974, Korean Air placed an order for 4 A300B4s with options for 2 further aircraft. This sale was viewed as significant as it was the first non-European international airline to order Airbus aircraft. Airbus had viewed Southeast Asia as a vital market that was ready to be opened up and believed Korean Air to be the key. Airlines operating the A300 on short-haul routes were forced to reduce frequencies to try and fill the aircraft. As a result, they lost passengers to airlines operating more frequent narrow-body flights. Eventually, Airbus had to build its own narrow-body aircraft, the A320, to compete with the Boeing 737 and McDonnell Douglas DC-9/MD-80. The savior of the A300 was the advent of ETOPS, a revised FAA rule which allows twin-engine jets to fly long-distance routes that were previously off-limits to them. This enabled Airbus to develop the aircraft as a